Assalamualaikum warahmatullahi wabarakatuh. This video is for Lab 3 Wireless Communication System ESP32 and MQTT Protocol Implementation. I am Nadia Shazli binti Muhammad Pisal. The other group member is Nadia Maisara binti Zaini, Siti Sarah binti Muhammad Hayazi and Muhammad Akram Arif bin Shahruddin. This lab project demonstrates wireless communication using the ESP32 microcontroller and the MQTT protocol. The ESP32 was programmed using the Arduino IDE to connect to a Wi-Fi network, publish sensor data, and receive control commands such as switching an LED on and off. The results show that the ESP32 can efficiently handle real-time data transmission using the publish or subscribe model, highlighting the importance of wireless communication in industrial network, particularly for IoT and automation application. Wireless communication is essential in modern industrial automation and IoT due to its flexibility, ease of installation, and suitability for remote monitoring without physical connection. In this lab, the ESP32 microcontroller was used as the main wireless component because of its low cost, built-in Wi-Fi and Bluetooth, and high processing capability. The MQTT protocol was applied to support efficient data exchange using the publish or subscribe model, making it well suited for IoT application with limited bandwidth. So the objective for this lab is to use ESP32 for wireless communication, to understand Wi-Fi and MQTT communication protocol, and lastly to send and receive data wirelessly using an MQTT based system.
Hi and Assalamualaikum. My name is Nadia Maisara binti Zaini and my metric number is 231363057. The ESP32 is the heart of our wireless communication system. It's an advanced microcontroller with a 32-bit dual-core processor running up to 250 MHz and 520 KB of SRAM for real-time processing. Its feature built-in Wi-Fi supporting 802.11b/g/n and Bluetooth both classic and BLE. The ESP32 also support multiple interfaces like UART, SPI, I2C, ADC, DAC, PWM, and touch sensing. Its low cost and high capability make it perfect for our IoT wireless communication project. Next, for our Wi-Fi controller, we're using the MQTT protocol, a lightweight messaging system designed for IoT application. MQTT uses a broker-based architecture where a central server routes all message. Device communicate through a publish-subscribe model. They publish to topics and subscribe to receive message. The protocol has a minimal overhead for low bandwidth usage and offer a quality of service level for customizable delivery guarantees. This makes MQTT highly efficient for wireless IoT communication. For our apparatus include the ESP32 development board as the main component, and LED with the resistor for our control demonstration, and a computer with Arduino IDE for programming. We also use a Wi-Fi router for network connectivity, an MQTT broker for message handling, a breadboard with a jumper wire for circuit connection. This component from our complete wireless communication system. That's all from me. Thank you.
Okay, so Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akram bin Shahruddin. So my number is 2301363 and 662. So today I want to present about the flowchart of this segment. So today I will talk about the throughout the operational workflow for setting up an ESP32 microcontroller to communicate with via MQTT. So this process cover everything from the initial software environment setup to final data visualization. So secondly is environment setups for the libraries. So our first step to prepare the Arduino IDE is we must install the specific ESP32 board support package so the IDE recognize our hardware. So additionally, we install the PubSub client library, which is standard for enabling MQTT messaging protocol on Arduino compatible device. So third is about hardware communication, port selection. So once the software is ready, we connect the hardware, and it is crucial to determine and select the correct COM port within the Arduino IDE. So this is ensure the stable communication link between the computer and ESP32 for the code uploading process. So fourth is about firmware deployment. So verify and upload. So with the connection established, we move to the deployment phase, that we have verified the code to check for an syntax error of the uploads edit in the ASP32. So this is step flash the logic onto the microcontroller memories. So after that is about the so after the uploads, so ASP32 execute the code. So the first task is controller performed as to connect to the local network. So this is provide the necessary internet of local network access required to reach the MQTT broker. So on this side of ni, we have installed the configure and mosquito MQTT broker. So this is act at post office of our data. So we run the initial testing at this stage to ensure the broker is actively listening for incoming messaging from ESP32. So visualization tool is MQTT Explorer. So to make the data of the readable and debug our topics, so we have installed the MQTT Explorer. So this is graphical tools that allows us to hierarchy of messages being sent across of broker in real time. And the final is integration and testing. So finally, we have the connect the Arduino IDE output with MQTT Explorer by monitoring both of the serious monitor and the Explorer. So we can confirm that the data from our ESP32 is being correctly received and categories by the broker. So this is completes to end-to-end setup. So thank you.
Hello and Assalamualaikum. My name is Tisara binti Mahayazi. Nama wajib saya 21366664. So for discussion, Throughout this experiment, sensor data was successfully collected using the ESP32 system. So the temperature and humidity reading were obtained from the HTU2X sensor through the I2C communication protocol. The ESP32 was able to connect to a Wi-Fi network and transmit the sensor data to the MQTT broker without any errors, just like in the video in analysis part. So two-way communication was also achieved using the MQTT publish and subscribe method. Control commands sent from the MQTT broker were received correctly by the ESP32 and the LED respond immediately, just like in the video. So this fast response shows that the MQTT protocol is suitable for real-time monitor and control application. So in conclusion for this lab, this lab has proved that the ESP32 microcontroller combined with the MQTT protocol is effective for the wireless communication. So it shows that the system was successfully connected to the Wi-Fi and publish sensor data and execute control command correctly. So throughout this lab, we gain a better understanding of the Wi-Fi communication and the publish or subscribe concept in MQTT that we use. The objective of this lab were achieved and the system shows strong potential for future applications such as IoT, automation and also remote monitoring. That's all from us. Thank you.